Hello, everyone. We're going to get started soon. Okay, so hi, welcome to the IETF meeting at IETF 117. Juan Carlos Zúñiga here. My co-chair Wasim Haddad luckily just had a new baby, so he's not able to join us this time. So I congratulate Wasim, but I'm having here the support from Eric and Carlos in case something is needed. All right, so cool. So as usual, the note well, a reminder that IETF policies are in effect, and by participating, you agree to follow the processes and policies. The information that you provide will be handled in accordance to this privacy statement of the IETF. And if you have information about BCPs, the way information is done or worked, or how we should proceed in the document, in the group, or how you should conduct yourself, please refer to these BCPs. So again, the note very well that we are reminding you. So please, we want to maintain an environment to understand and work together here for technical purposes. So please be mindful about the way you proceed, the way you express yourself, and be as technical as possible. Avoid any direct or personal statements. We believe that we are inclusive for multiple cultures and ways of being. So, all right. So, in-person participants, as usual, please sign into the Mitico client. Carlos, could you please pass the QR code just so that people log their attendance? It's the same as the QR code that you have in front. That'll be useful for us to follow up on comments and keep track of the queue, etc. So please do sign on. And as usual, for remote participants, please make sure your audio and video are off unless you're sharing or talking. Okay. So these are the links to the agenda, the Mitico, and other information. And if you have any issues or requiring assistance, please log on to those resources. As a reminder, the minutes are taken. We are going to be recorded. No, I'm going to get to that. Your presence is logged, and we need Scribe to contribute to the minutes at the notes IETF117 area. Do we have a minute taker for the session? This could be a community work, so even if you are presenting, we can ask people to help. But can someone help us taking notes for the discussion, the main points? Any volunteer? Please. We need a minute taker for the session. Online too. Can someone help us here for the minutes, please?
Okay. So Eric Ving has the responsibility for this. We cannot start without a minute taker. He's simply taking the note of question. Oh, we have one? Thank you, Luigi.
Luigi. Thank you very much. Merci beaucoup. Grazie. So this is our agenda for today. Pretty similar to some other meetings. So we have just 6 items. We're going to go quickly through the document status. Then we're going to hear about the status of IANA considerations and IETF protocol and documentation usage of IEEE 802 parameters. So we'll hear some feedback from Glenn about the discussions, the review of the last version, that there was a review at the IEEE 802 meeting recently in Berlin. So we'll hear back from that review. And Donald is here also. We'll have a chance to understand what the status of the document and what are the next steps. Then we have Valdemar on the IP addressing with references. Then we have Tommy with communicating proxy configurations in provisioning domains. Trusted domains are SRv6 with Andrew, and civic location and geospatial coordinate support in IPv6 and D with Sri. Any comments bashing on the agenda? Okay, hearing none. So, as a reminder, the group updates, we received this liaison letter and we exchanged a couple of messages with IEEE 802, specifically 802.1, about the document that Donald has produced, the RFC 7042 bis. And the group has reviewed this document and we'll hear the details from Glenn directly, but this is something that has been going on. Some other updates. This is just, I guess, in the back burner. We already discussed about it. Related, but not the same thing. Some discrepancies in existing public ether type lists that have been identified that we will need to follow up with IEEE 802 through the coordination committee that we have between IEEE and IETF, IEEE 802 and IETF. And that's also to be continued. And that's pretty much it from the working group updates. So if there are no more comments or questions, then I guess we can move to the first presenter. So let me see. So the first presentation is about the feedback from IEEE 802.1. I have the document here. I don't know, Glenn, would you like to come up and, yeah, as you,
Okay.
probably here,
Yeah.
just for the Miteco people to see you better. But do you want me to show the document, or you prefer just to?
Well, you can if you want.
Probably better just to provide some feedback.
Yeah,
on
I'll
the,
just provide some feedback. So I'm Glenn Parsons with Ericsson. I'm the chair of the IEEE 802.1 working group as well, and I want to thank the in-area working group for sending us the liaison. Originally, and we provided some comments, and then with this latest draft, it came at the end of our plenary, but we still are thankful for you letting us know. And we provided some small comments. Most of them are editorial comments that we noticed that were not included from our previous comments, but there were a couple of, I guess, technical comments on the MAC addresses, on how they're defined, the differences between the global addresses, the use of the M bits, and whether that's in the global address or the unique address. Minor nits, I would suggest, and they're in the document that we've sent. So we sent it back to the working group chairs and through statements, I think. So so there's about 20 or so comments. As I said, most of them are editorial. A few little technical ones in there that we suggest that you take into consideration for the next version. So
okay,
that's really all I had to say. So
okay. Well, thank you very much. We appreciate the accommodating at last minute your review.
Yeah, no, for sure. Yeah, no, and I appreciate that you were able to send it before we closed our meeting, so we were able to then initiate the review. So that was great.
Yeah.
So thank you for that.
So that people are aware. If we hadn't done that, we would have delayed.
It would have been till the next time we met in November.
So November. So
Yeah.
so it was very good that we could coordinate and do this on time in Berlin. Thank you.
Great.
So, yeah, do you want to respond,
You can
Don?
come here.
I just want to say the slide save 06 is actually, I posted another version this morning, 07, which responds to IANA early review comments. So the only changes are in the IANA considerations section, none of the rest. And I've looked at the comments from 802.1 and I don't see any problem in incorporating them, and would expect to do that and post another revision this week sometime.
Okay, thank you. So we have a comment from Gory. Are you online or person? Gory? Yeah. Or maybe Gory is raising his hand without realizing. Okay, so okay, fair enough. I guess that's it. Thank you very much, Glenn and Donald. So we will expect, I guess, a new version to be produced soon. Don, and once you send it out, I think it should be pretty much ready, assuming that you're addressing all the comments. Thank you. Okay.
I just said I need to make a presentation in another meeting, so unless there's something else, I will be departing this meeting.
Okay, that Don has to take off. Yes, thanks. All right, so next on the agenda is IP addressing with references from Valdemar. Yes. You want me to share? Okay. Okay.
Okay, I'm going to be talking about the updates to the IP addressing with references. There have been 2 updates. I'm going to be talking about one of them, and that is adding some information on how IPref is used. Next slide. And in this, I am also further focused on one particular use, and that is with IPv6 Internet and IPv6, IPv4 interoperation and impact on both of them, IPv6 and IPv4. So there are 3 key features of IPref which play a role here. First of all, this is an end-to-end address space traversal. Can work over NAT, NAT6, it can also work across protocol, IPv4, IPv6.
Sorry, could you speak closer to the mic? Remote people cannot hear you very well.
Not sure. Yeah, okay. It is highly scalable and commercially viable, and this is really a prerequisite because without that, there would be nothing to talk about, really. The second important feature is the addressing IPref addresses being publishable via DNS. So that is important because all of the services through IPref will be available from any addressing. The third feature is compatibility paths for specialized protocol. I am really excited about that because I think there may be cases where a use of specialized protocol would be useful, and IPref provides the instantaneous compatibility path with the internet. So those are the cases.
Sorry, now they say it's too loud.
Too loud. Okay.
So, sorry about that.
Okay, let's try that. Okay, some of those. Okay,
Yes, keep going.
Warm cold.
Back off mechanism.
Okay, I need a feedback on this. Negative feedback. So, for example, like space networks are actually not close to this, so I don't know, but I can imagine there may be a situation that because of the fuzzy time domain, there may be need for something special. In other cases, IoT, I'm much more confident about that. I'm a little bit familiar with Sprinkler networks, like for agriculture, and that's the case that could really use some really simple IP light, like address maybe 2 octets, the header maybe 8 octets, UDP only, that sort of thing. So IPref would provide, again, instantaneous compatibility. Another case would be highly secure networks, maybe financial, maybe military, that could use something special. And actually IPREF alone is already should be happy about that because of not disclosing the internal IP addresses, and the references which are light, you can discard them, you can do a lot of things with that. Next slide. So with this, the IPREF impact of IPv6 is really summarized in the first bullet item. What I think is going to do is going to speed up adoption of IPv6 internet substantially. And this is because of the new adoption strategies. And chiefly among them is the ability to actually work with IPv6 while still sitting in the IPv4 in your local network. So you can change it later if you want, but you don't have to replace everything to connect it. And another interesting thing I think is going to happen to IPv6 is that IPREF is going to make it focus on the internet a little bit. And more specifically on connecting networks, okay, not hosts, like it's internet, right? Which might not necessarily be IPv6. And also IPREF is gonna allow IPv6 not to have to be everything to everyone, which I think is gonna be useful. I'm also really excited on the non-technical aspect of this. See, I think IPREF is going to spur some substantial economic activity around networking. It's not just, you know, the transitions, the gateways, the architecture, services, all that stuff. I also think there's going to be innovation around that because IPREF brings some new possibilities here. Next. Impact on IPv4 needs some context. So the context to that is the so-called shortage of IP addresses. This is a term that is no longer accurate. It was accurate some 25 years ago, but these days it's a bit of a misnomer. That's because there is no shortage of IPv4 addresses. Something else is a problem. So how does IPv4 extend 32-bit address space? It does that by hierarchy. So there is a high-level 32-bit space, and there is a NAT, and there is another theoretically 32-bit space, but in practice it's like 24 bits or so, at least. Now this obviously creates a problem because those new IP addresses, they may exist, but they're hard to reach. So that creates a problem known as NAT traversal, and something that I would like to rename to address space traversal, because this is a little bit wider issue than that. So that problem was solved partially by assigning global IP addresses. This works only one way, but that's okay because most of the services are client server type, so say it works, so that's fine. Now, IPREF brings complete solution. IPREF works like peer-to-peer and across all of these address spaces, including IPv6. And remember, those addresses are also publishable, so that's effectively solved that problem completely. So the impact on IPv4, the first thing that we have to say is that indeed IPREF makes IPv4 internet possible. There's just no way around that. We need to know that. So all of these extra IP addresses, like with this two hierarchy, you get like 32 plus 24, so like 56 bits. If you're doing something like CGNAT, you're getting another level, so it's like 3 levels with another 22 bits, so it's like 78 bits of IP addresses. And they all are reachable, they all can publish services, they all are in DNS, everything works. But I think IPv6 will prevail. It will prevail. Why is that? That's because IPv6 is flat, and flat is better than hierarchical. I also think that even the slightest prospect of competition will make IPv6 focus. I guess There's some really smart people there, and they figure out how to make it more useful. Okay. IPRF, incidentally, this is interesting. IPRF does make this IPv4, potential possible, but it also gives IPv6 means of winning out. And this is because the way IPRF works, the host that communicates with the other end actually doesn't know what that other end runs, doesn't know what those IP addresses are, doesn't know what that other space is, and doesn't know what the protocol it is. So IPv4 host may be talking to IPv6 host and doesn't even know about that. Even more, even if you does know it is actually IPv4, but there is an internet between those two, and that internet may or may not be IPv4. It could be IPv6, and it really doesn't matter. And the communicating hosts don't know about that. So at this point, it's like, what do you care, right? It might as well be IPv6. So this is the reason why I think eventually, no matter what, IPv6 will prevail. I'm particularly seeing this because it's a special network. It requires some specialization which IPv6 can afford to do, whereas IPv4 can't. There is still something for IPv4 in this. You will be able, if you're running IPv4 network, to keep it as long as convenient, even though you're connected to IPv6 network. And you may convert eventually. I'm actually not sure how it's going to work out, but I mean, what is going to happen exactly, but that alone, I think, is advantage. And you will also be able to do away with dual stacks. So that's all I have.
You want to show? No.
No, I don't have time for this, so I'm not going to be talking about it.
Okay. Thank you very much. There are some comments on the list. I don't know if you guys want to ask some questions. We have 4 minutes.
So everything clear, I guess.
Eric?
Eric, yes, Eric Vink, as a no head at all. I would suggest if you can explain for the remaining 3 minutes and 40 in 2 minutes, what is the ID behind the draft in 2 minutes?
Can we get back to the
Technical description, basically.
first?
Which one?
One more back. Yeah, that's it. So the first item is what the idea is to provide end-to-end address space traversal. And what I address space mean with the thing behind NAT, so to speak, and also connecting IPv4 and IPv6. As it turns out, it is exactly the same solution that works for both. So the way it is designed, the way it is accomplished is through the use of the references rather than real IP addresses, okay? So this works because when you really think about that and work on this, then you notice that the host that originates communication actually does not need to know what the destination IP address is. So we can, so instead of trying to figure out what it is and communicate to the IPv4 host what the IPv6 address is, we just don't do it. We just allocate a reference that represents those. And the reference is just an opaque number, okay? And then when the packet eventually reaches the target network, that target network has enough information and context to direct it to the correct host based on the reference. So that's how this works. And because it doesn't use any negotiation, there's no negotiation necessary for this. There is no global configuration necessary. There's no shared information that is required. this produces an incredibly scalable solution. So this is real. You can actually connect V4 to V6 and not even know about it. You can go behind that. You have like carrier grade NAT, which is like a 3 level of NATs. Okay, still works over that, no problem. Because you can publish DNS in a DNS those IPRef addresses with those references. Then you're basically getting everything that you will get in a standard IP network. You can have a server behind 1 NAT, 2 NATs, 3 NATs, whatever. You can publish it in the DNS, and there's some other hosts, whether IPv4 or IPv6, can reach that server. It also works with peer-to-peer systems. So yeah, it sure does with this client server, but also works peer-to-peer.
Okay, thank you very much. So, well, we are out of time, but I think, well, you will see and you'll have a chance to respond to the chat. That's probably the problem statement that will need to be addressed. Some people, I guess, that's more than the solution, is the problem that they're trying to solve, what they are asking about. But I will let you go that through
Just one.
Okay, 10 seconds.
Half a minute, okay? Problem statement is very simple. We've got 2 internet. We don't need 2 internet, okay? You can have 1, but this conversion is not going very well, okay? It's taking 25 years and we still have 2 internets. This will speed it up tremendously.
Okay, thank you. All right, so I'll let people continue the discussion on the chat and mailing list. And now we have Tommy with internet, with the configuration of provisioning domains. Cool. Should work. Nice. Yes.
Okay. Hello, everyone. I'm Tommy Polly from Apple. Good to see everyone in INTAREA again. We had, last time I was up here, it was also talking about provisioning domains a while ago, but they're coming back. So we're also going to be talking about proxying, which is a topic that has also been talked about a lot before in INTAREA. Back, I remember when we went over SOCs quite a lot in this group. So this is combining those two. So let's talk about what we're trying to do here. All right, so there are 3 different use cases that I think fall into this intersection between proxy configuration and PVDs that have come up a lot. For us recently, we're doing some new stuff with proxies around mask, so some more secure HTTP proxies, but it applies in general. So first we have the whole category of network provided proxies and how can we discover the network has a proxy associated with it. Then there's a question of, I already know about a proxy, I want to find a related one. And finally, I want to understand something about how this proxy applies to traffic and what it is able to support. So to illustrate each of those cases quickly, first we have a network provided proxy discovery case. So a client is connecting to hosts through a network, and the network has associated with it, or it's directly providing one or more proxy servers. Maybe that's a mask proxy, or maybe it's a SOCs proxy or something else. There are a couple of different use cases where this is interesting. I'm sure some people are familiar with cases where networks already provide proxies, oftentimes to be able to filter content on them for enterprise scenarios. But we also have cases coming up, such as the 3GPP proposal around something they call ATSSS, where you have a proxy in a network that can support multipath access, so you could migrate connections across Wi-Fi and cellular links if you have both of them provided by the same ISP/carrier. And that is a case where it's kind of an open question about how would you actually discover the presence of this proxy. So this is one use case. The other use case, the second one, is when we have a proxy I already know about. So let's say I was configured in my system settings or some enterprise profile, oh, use this HTTP proxy. And that's all well and good, but maybe I want to discover other properties about it because there are new proxying protocols that can support proxying UDP over HTTP or proxying IP over HTTP. And I want to know, does it support that? And if it does support that, I need to know the URLs or other properties about how to get to this thing. So how can I discover what's related to the proxy I already am on? And lastly, some proxies may not apply to all traffic. This is very similar to what we would think of as like a split DNS case for a VPN, but here just in the proxy world. And VPN protocols like IETF2 allow you to communicate their split DNS configuration, but there isn't a great way to do that with proxies yet. Okay, so if you're familiar with the current proxy ecosystem, you may be thinking of, oh, but there's PAC files and there's WPAD, and that solves proxy discovery, and that lets you learn about which host name should go for the proxy or not. But for various reasons, I'd like to not reuse that solution going forward for new things. So these, first of all, aren't actual IETF standards. I think they came about during the 90s around Netscape development and other things. They require running a lot of JavaScript parsing that has a lot of big security concerns when we're having to run PAC scripts today on our system. So I'd like to avoid building more of that in just to learn a split DNS list of domains. And these also don't work with new proxying types. We're seeing a family of new proxying types coming from MASC and the HTTP working groups that are based on full URLs, and PAC files as they are defined always have a host name and a port, and they just kind of don't, they would need to get overhauled anyway. So I'd like to avoid doing this. I think we can do a lot better. And I think we can do a lot better with PVDs or provisioning domains, which is something that came out of INTAREA. So raise your hand if you remember what a PVD is. All right, that's pretty good. Woo. Okay, so PVDs are here to help. So they were defined originally in the multiple interfaces working group that was closed, and then we finished some of the work here in INTAREA. So 7556 defines PVDs as the architecture and the concepts. PVD is a consistent set of network configuration information. And then 8801, which was done in INTAREA, does essentially two main things. It has a V6RA option that allows you to explicitly name a provisioning domain, handle multiple RAs from the same router to say you have many different uplinks, and also to associate additional information with a particular PVD. And that's this JSON dictionary that can be fetched over a secure HTTP connection to say, here's other properties that I don't want to stuff into my RA. It's the place where you can spill over and have potentially a long list of proxy URLs. Maybe we could use that. All right. So dwelling on PVDs a bit more, what are PVDs? What are some examples of when we have them? And the common ones are we have, my Wi-Fi uplink. I have a router. Maybe I have one or more PVDs from it. My carrier network is giving me at least one PVD, but if I have different slices or APNs, those are each technically a different PVD, and I may have different local addresses and different DNS configurations, etc. Every VPN tunnel is its own PVD. But here's something that I don't think we ever really explicitly stated before in PVDs, but a proxy itself is a PVD. It is a way to access a particular network. It is a type of tunnel. You don't generally do DNS over the proxy, but it does DNS for you. And it is its own way of accessing resources. And so a network may have a proxy as part of its configuration, but then that proxy itself is yet another tunnel or sub configuration itself. It is a provisioning domain. And so that is the kind of the philosophical leap that this proposal is based upon. So the document is really doing two technical things, and this is just a 0.0 document, and I think there's a lot more work that would need to be done to flesh it out and add all the considerations we would want. But fundamentally, it allows you to, given a PVD that you know about, you can enumerate proxy URLs that are associated with that PVD, saying that, hey, my provisioning domain has proxies or other proxies associated with it. You may be interested in them. And secondly, you can fetch a PVD configuration for a proxy itself, particularly if that is an HTTP defined proxy. So I'll just go quickly over what those mechanisms are. So first, here's an example additional information JSON dictionary that we already have for PVD. It already has an identifier and expiration and prefixes. And then there's just one new key, which is an array of proxies. So you can enumerate those. And in this case, I have one HTTP proxy and one HTTP proxy that supports UDP. And that's this URI template thing. But that could be a SOCKS URL or any other type of thing. So you say, I have these proxies. There's an open question here about, do we leave it implicit what the types of the protocols here are, or should we have an explicit nested structure? That can be a nice little bike shed discussion we could have. But fundamentally, it's like, let's have a list of proxies associated with a PVD. It seems like a reasonable addition to have. And then the other mechanism is, if I know about a proxy already, how do I fetch the PVD that belongs to it? If I want to learn about other proxies, or I want to learn about details that may only be configured in that dictionary, like what are the DNS domains? As the document is written now, you do a get to the URL of the proxy, and you use the content types that are defined already for PVDs. We talked about this yesterday at the MASK working group meeting. I think there's a suggestion to instead just use the name of the proxy and fetch it off of the well-known /PVD, which is already defined. That sounds great. I can change that. But fundamentally, it's like, if you know about a proxy, here's a way to get to a dictionary of things about it, which may include other proxies or may include other information. And then one specific piece of information that's useful here is we already have DNS zones that belong to a PVD. This is an optional key. And we can define things such that if you have a proxy provided PVD and it gives you a list of DNS zones, it's telling you these are the zones that I'm going to be able to give you access to. If you go outside of these, I may not be able to respond. So it's kind of a hint saying, if I have many different proxies, that this is a way for that proxy to tell me, oh yeah, I'm only used for remote access to my enterprise, and I'm only going to be able to resolve these. As an aside for the use case here, recently on Apple platforms, we have support for using Mask essentially as a VPN replacement, and Cisco has built support for that. And this is one of the things that they were wanting to have, that rather than forcing clients to have a static configuration of the domains that belong to a particular proxy, the proxy could update this list and kind of cut that list down as their configuration is dynamically changing. So I think this is something that would be useful. It's something that VPN protocols already have. Lorenzo, did you want to jump in? No, okay, I'll get to the end. Almost done. Anyway, so there's a question, I think, of venue for where this is appropriate. When we discuss this in Mask, I think this is an area that people working on these types of proxies believe is useful to solve. I believe it is explicitly not within the charter of Mask. I don't think it necessarily fits within HTTP, since this could apply much more broadly beyond HTTP proxies. It includes SOCKS, etc. So I'm here to share this with INTAREA because this is where we worked on the notion of PVDs and the notion of the PVD additional information. And this is really just extending that with a couple tweaks. If people have thoughts, though, about venue that are not here, I'd love to hear that. We're also working on some basic implementations with PVDs from RAs as well as proxies, and we'd love to test this with you if you're interested. That's all from me.
Lorenzo?
Yeah, I'm wondering, like, I'm wondering how to say this politely, but I won't. Can we use this to kill pack, please?
Yeah, please.
So, so not to the extent of running the JavaScript interpreter here, which, I mean, yeah, I guess these days you'd never design it that way. But if you scroll back to the yes, what other attributes, right?
Yeah.
I mean,
Oh, sure.
what do we think we might need to sort of basically stare down people who want pack and say, no, we don't want to do pack anymore? What would we say? Regex for URLs, perhaps? Because pack runs arbitrary JavaScript, but what do we know what people use it for? Any idea?
I mean, I know the ones I've seen. I know, and I've had some email conversations with people who have, lots of pack deployments and strong opinions about how their enterprises work. I think that would be, if we decide to do this work, I would be very interested to, start with something basic here, but then before we publish, do that work to reach out to people who are using pack a lot and, fill in the registry of keys with what you need to have a viable replacement. And of course, the registry can continue to be expanded, but this is an opportunity to figure out that set of things to, at least in a lot of cases, remove the need for pack and WPAD.
Thanks.
Ben Schwartz, Meta. I'm very supportive of this kind of work. No surprise.
Yep. You inspired a lot of it, Ben.
Thank you. I think this would be a great opportunity to update RFC 8801 and try to explain a little bit more clearly what the DNS zones key means.
Yeah, I agree.
Great. So yeah, let's just, I don't, yeah, not in HTTP BIS, not in mask. I don't know if whether it's an int area. I think depends on how ambitious we want to be in terms of trying to cover more cases from pack, in terms of trying to imagine how to support things beyond the HTTP based proxies, like can I put an IKE v2 gateway on my list of PVD supported proxies? Like, there's kind of no obvious reason why I can't, but I don't know.
Yeah. And just to call out, for those who haven't seen, Ben has written up, previous versions of how we can do configuration and learning about what a particular proxy supports. And so I think there are other keys and information in there that we may want to review and pull in as we think is appropriate, kind of similar to how there are things from pack that may want to live here.
Okay, Eric Vink, this time as a RFC 8801 co-author with Tommy and a few others. So fascinating word indeed. And indeed, DNS zone should be a little bit more expanded. That's easy to say. Regarding of my ADA, I think INTAREA is mostly the most suitable area right now, except if we extend the word, as you said.
Yeah.
So thank you.
Okay.
Hey, Tobias Siebig, Max Planck Institute for Informatics. Just some input on how pack is being used. So for me, the main tool is making people able to use an HTTPS proxy, because most browsers simply refuse to use HTTPS tunneling on the proxy itself, which of course is kind of nasty for authenticated things. So
do you mean using TLS to the proxy?
Yes.
Yeah.
So keeping that maybe in mind a bit more, like how can we not only build auto configuration around it, but also encourage adoption of user configurability.
Yep, that's a great point. And that is another area where, the era of pack files, you never did TLS to the proxy. And we want to kind of have a reset, like the modern version of these things, should be able to do that by default. And that's something that within software on our platforms, like this year, we have native support for that, but we need a configuration mechanism to have this come from the network. Yeah, great. Thank you.
I close the queue. We have a minute. I don't know, Lorenzo, do you want to say one last comment or you're good? Okay. All right. So thank you very much.
Yeah, thank you. So yeah, we can have more discussion on the list, and I would ask the chairs, if it's something that, based on this discussion, if you think it's appropriate, that we could talk about adoption at some point.
Okay, thanks. Yeah, being a 0-0, I think it's early to call for anything, but that was good start. Thank you very much. All right, next is Andrew. No, give me 1 second. I'm switching between screens, so
That's fine.
sorry.
So just wait for you to change. Hello. So firstly, I'm here to talk a little bit about trusted domain SRv6. And yeah, thanks for being around to listen to this. And we really hope to get some good feedback. So why does this document exist is the first question I get asked. So SRv6, as it stands, has known security vulnerabilities. Particularly when you manage to get a packet into the so-called limited domain. And those security vulnerabilities are documented both in a security considerations draft and in a mail thread on the V6 ops list, etc. And the links are in the deck. But 8402 says that SRv6 that leaks beyond the boundaries of a domain creates a security violation. 8754 says that to mitigate attacks, filtering into the domain is required. The only current way to actually limit the domain is through LPM filtering. Now, there are some operators out there somewhere that may argue that they can do that on every external port in the domain. I would, for myself and for many other people I've spoken to, argue that LPM filtering on every external port on a broad scale is neither practical nor is it scalable. And I just want to point out that if you look at operators' history with prefix filters over the last 20 years by taking a look at the BGP tables, well, I think that should give a pretty good indication as to how well operators handle prefix filters. It's not a good picture. So I've put some links in the deck there. I'm not going to go through them, but I think that those two links, one of them highlights some pretty specific attack vectors. The other is a more general security considerations draft. So if you're interested in hearing about exactly what the security considerations are, take a look. Otherwise, you know, myself and my co-authors are quite happy to have this conversation with anyone at any time. So what does the draft attempt to accomplish? We want to give operators that feel that it is necessary to protect themselves by closing the domain a way to do this. So instead of saying that your domain is closed because of some LPM filters, which are pretty error prone, we want to make it fail closed if the operator chooses to take that option. So we are giving them an option. It's not mandatory. We are hoping that people will actually take this option, but we're trying to create an option. We wanted to keep this really simple. We know that SRv6 is out there. It's deployed. Rewriting SRv6 now wouldn't work. There's been a lot of work into it. There are some people who love it. We need to keep SRv6 intact while at the same time fixing the security flaw. And we need to maintain all the SRv6 functionality while allowing SRv6 to be used in the context of a trusted or closed domain that fails closed. We wanted to avoid a situation that would require changes to silicon. And We did a lot of checking on this, and we've yet to find anything that can't rewrite an ether type. There may well be hardware out there that can't, but the majority of hardware that we've looked at, we've not found a problem with the ether type rewrite and the change in the pipeline here. We also want to enhance the deployment of SRv6. There are a lot of operators, myself included, that may have a use for this. However, until we close the potential security issues, it will never be deployed on certain networks. And so by creating an option for operators, we actually potentially increase the deployment of SRv6, which people have put so much work into. So how do we accomplish this? We're proposing a global knob on the device that says this device runs in trusted domain mode. If that knob is enabled, no SID processing is going to occur if the SID is contained in a packet outside of the packet with the trusted domain ether type. At the same time, we put a per interface knob on the interface that says enable the processing of this ether type. What you've effectively got then is an MPLS style fail closed domain. Enable MPLS on the interface, otherwise the packet arrives, the packet's getting dropped. The per interface method proposed here, as I said, is the exact same thing that has been used on MPLS. And interestingly enough, I heard yesterday that back in the days of MPLS TP before me, before my time, that came to the IETF without an ether type, and we told them put on an ether type because of security reasons. So there is actually precedent for us going, please can we have an ether type for security reasons and possibly others. Next. Just another note. We don't document the methods to do this because they contain their own risks and they're probably out of scope of this document. But we do believe that it is also possible to enforce the trusted domain ether types right at the borders and then drop back to standard processing internally. That has its own set of risks. We've chosen not to address them in this draft, but it could potentially be used to allow the V6 processing on devices that don't use it. Whether or not that's a good idea is another story. We haven't chosen to address that, but I just wanted to make clear that it is potentially possible. I see a question from Tom. Do you want to jump in now or?
Hi, Tom Herbert. So I'm sorry if I'm preempting, maybe you had a discussion plan. Where is this ether type? Are you actually talking about Ethernet packets that contain this trusted domain ether type, or
Yes.
is it shared elsewhere?
No, we're in the same way that a V6 packet has 86 DD, an 802.1Q packet has X, a V4 packet is a 0x800, I believe. We're proposing on this to put another ether type in there to explicitly delineate this as an SRv6 packet.
So this is kind of like saying SRv6 is really no longer IPv6. We're redefining it to be SRv6. So we've had that discussion before, right?
100%. The difference is here, we are saying that this is an option to allow operators to choose to run it as IPv6 with the security concerns, or run it as its own protocol.
So it's great that you're saying it's an option, but I'm just wondering all the ramifications of introducing a new ether type on the network. I doubt that's the easiest thing in the world, right? Because you have all the routers, all the devices, all of a sudden using a new ether type, is that feasible? And the other point is this is actually kind of munging layers, right? So we're using this ether type as a pseudo new protocol, even though it's still, for all other purposes, IPv6. The other question I have is, how is this any different than if we just look at the IPv6 packet? We see there's a routing header in there. Why not just filter that at the edge of the networks instead of doing LPM or anything fancy?
Okay, so let me address that last question first. You do not need an SRH to run SRv6 in certain cases. Explicitly, there are cases where you do not need an SRH, and you can run SRv6 in the absence of that. That's the problem of filtering on the SRH that may or may not be there. And in fact, we did a fair amount of testing on this and found a number of cases running SRv6 without an SRH. That left us with only the LPM filtering. As I said, we believe that's got issues. The other question about, is this potentially difficult? I would say that when you go out there to enable MPLS on a network at stage, right at the start, you have to go out there and enable every interface for MPLS. If you are deploying SRv6 in a greenfields environment where you've never deployed it before, it is no more difficult to do that than it is to turn on MPLS. It's the same, turn on the knob, etc. Yes, you may not be able to do this across devices that don't support it. Same thing with MPLS. But that is an operator choice. The operator gets to choose, do I say that everything needs to run this, and I can run this in fail closed, or do I accept that I'm going to run it the other way, have to LPM filter anything, and hope I get it right?
All right, but it's not just about turning up a new ether type. It's also about the management, the tooling, all of that has to change, right? So I think on one hand, you're saying don't change SRv6, and that's a very noble goal. But the alternatives, they sound pretty invasive in the network. Like I said, the nice thing about if you can push this problem to the edge and just do filtering, the nice part about that is that compartmentalizes the problem at the edge. But this is exposing this new ether type to all devices, right?
Correct. And at the same time, I would say to you, what is your edge? The cloud stack that's got 4,000 VLANs facing servers that your customers have got access to? Your transits? Your peers? Your customers? What is the edge? That's the problem. To say it's just constrained to the edge means that you have to have a clearly defined edge. And I would argue that for a lot of operators out there, that's simply not the case.
Okay, so let me follow up. I have one more sub question. So if there's no edge and you're using a new ether type, what prevents forwarding the packets in that ether type outside of the network?
Because if they're going outside of the network, typically I'm only going to enable the processing of that ether type on the ports that I know that it is needed. It is default when I've got this enabled to that ether type processing not being enabled, the same way that by default MPLS processing doesn't leak because you've got to explicitly enable it.
But this ether type is containing IPv6. So an edge device sees this and forwards the IPv6.
It won't. And the edge device is going to say, well, won't know that this is v6 because it's got the ether type on it.
Okay. I guess I just don't see how having a new ether type for the same packet format potentially helps.
Okay, thanks. We have to move on. There's a big queue now. Tianji?
Tianji, China Mobile. I'm glad to keep mentioning about you try to solve the operators issue. We are the largest mobile operator in the world. We have close to 1 billion subscribers. So I have to talk about this thing from two things. One from the tech-wise, one from the business development side. But the tech-wise, I'm glad you mentioned like you are using 0x800 for regular Ether, 0x8100 for the .1Q, and 86DD for the V6. Since those are the Ether type, the real layer, like a big one. But now you're trying to use something, it's like a bigger patch for some very smaller things. So you try to define a new Ether type that's on the same equivalent class, like the 0x800, 0x81.1Q, and the traditional V6. So it's like why now you do the same thing for IP over IP, GRE tunnel? You can use the Ether type to do the same thing and do the security. Oh yeah, we do not want nothing. We can define a new Ether type for IP over IP tunnel, for GRE tunnel, all kind of tunnel. So that is the tech-wise I want to argue. The second one is as operator, because you keep mentioning operator part. The thing is for this SRv6, we have deployed, we have the largest, the network, including both mobile and mobile wireless, mobile IP. Well, if you look at the 5G part, we have the N3, that SRv6. We have N9 SRv6. We have N6 interface SRv6. And we have the data network with SRv6. So things we have deployed already. We have used like the prefix filter. We have like the ACL, all kind of firewall options have been deployed. So things like now you're trying to introduce something. Like I think Tom mentioned the managing part, the configure, reconfigure, unconfigure, all kind of things. I think it's just like make a bloom the things. So that is the both things I want to argue. Thank you.
Okay, so I'm just going to respond very briefly because of the queue length. So let me take the first one. We say that using an extra Ether type on the same class of things is somehow a problem. So I'm not sure I agree with that. And I would also counter that saying, did we not do that when we created SRv6 and introduced a layering violation by using the v6 address in the way that we did, in a far worse manner? On the second point, with regards to the operators that have deployed, etc., we are not telling anybody out there who has deployed this that they have to do this. This is an option. And there are operators out there that are not running SRv6 and never will until this issue is solved. We are saying those operators want an option. That will not change on your network. It will not change anything on your network because it's an option.
The things like you're not going to change anything, and that means the IETF has the tool already in place to handle the issue. Now you try to reinvent something to handle something not necessary to be handled in your way. So that's the argument.
Thank you. Tony?
Tony Lee, Juniper Networks. I've been building routers since 1991 professionally. And I want to speak to the point that an Ether type is too hard to do. As compared to the rest of the code that's going in for SRv6, an Ether type is noise.
Ron?
The rest of the queue. The Tony P. Juniper.
Sorry,
There
Ron?
are other people, right?
I'd like to strongly support this draft. The base SRv6 draft, the SRH draft, in its security consideration section, talks about the security issues and that it must be run in a limited domain. Well, the problem is it's sometimes very difficult to build those ACLs that keeps SRv6 in a limited domain, especially when there's no SRH in the packet at all. Then it becomes very difficult. The amount of effort that's required to implement this option is really pretty nil, pretty slim. And I can't see why anyone would object to it.
Tony P. Juniper. So I'm building router probably 4 or 5 years less than Tony Lee. Still, This is trivial, and I do not understand the objection by the people that deployed it the way it is today. Good luck to you. You want to build, you know, TCAMs of bazillions of entries. Nothing prevents you. It's a limited domain. You don't have to change anything. People who want to have a simple security domain, especially without doing anything, because if they don't enable the address family, the default behavior is drop, right? That is a good option. Ether types are trivial to put into ASICs and process. And I also check with majority of people, you know, how painful that is. And that seems to be very simple, you know, operation to add this kind of Ether type support for DES-RV6. So yeah, that's pretty much it, right?
Thanks.
Dan?
Dan.
I'm here. Dan Boyba, Canada. So Andrew, I find your document is based a little bit on the perception that the operators have a hard time to run their network. And I know that by your slide 2. I've been upgraded to this mic. So that's the perception I have from the document, but I'm not against the fact that you're proposing an option, although there's a bunch of downside to it. And maybe we should have like a, I don't know, a best practice of how to secure something like that. That could be informal, but in this document, it's a track ID. And I don't think we should tell operators how to do or have the assumption that you made in your second slide, the last paragraph. There's a very good solution there that could be deployed easily. Like if you're running with, I don't know, 4 million CPEs or CEs and 100,000 change a month, I mean, you have to have a way to automate and then push in the TCAMs that you were talking about. So I think there's a better way to address what you're trying to say, but I'm not against your way of proposing options, although there's a couple things that should be fixed, as what we heard. But let's not take for granted that the operators doesn't know how to handle their own network. I think we know pretty much how to handle our network.
Okay, so Dan, I just want to say, I don't think that was ever my intention to say that. And I apologize profusely if it came across that way. I think that in my view that the scalability problems around LPM filtering occur not just because of human error. They occur for a multitude of reasons, tooling, etc., etc. And there have been a lot of prefix leaks in BGP. No, I don't think anybody is going to deny that. And I was simply saying, and I did not mean to imply in any way that any operator didn't know how to run their network. But to be human is to make errors. That is part of being human. That is part of being an operator. We make mistakes. This option is designed to avoid those mistakes. Because as operators, I will be the first to say, I've made mistakes. It happens. This is merely to try and reduce that.
Some downside, like you heard just before. So the mistakes that you're talking about, the truth is there's always going to be bad neighbors, internet neighbors, and good internet neighbors. Nothing can prevent that. We see that with BGP and prefix hijackings and things like that. But I will not assume that this is the only way, because there's a good tax that comes with your solution. Like the IPv6 in the middle knows now it's gone away. So it has a drawback on the rollout of IPv6.
It does have a drawback. And I'm not saying this is the only solution. I'm saying we need a solution. And right now, I don't see another solution. If somebody has one, we're open to hearing it. 100%. I'm not saying this is the only draft.
We should have vendors then come to the mic and talk about the TCAM that you're talking about with the PRM solutions. So it's pretty scalable. I haven't seen anyone there that says, no, my hardware is not scalable for that solution.
It's not just the hardware. It's a management issue as well.
But management is up to the operators to decide what to do there.
100%. But an operator also has the choice to get that right, not get that right, do that. We are simply saying to the operators, Here is another choice. Where's the
Make
problem
it
with
optional.
saying it is optional? That's the whole draft makes it optional. It is a choice to enable this or not, or run this in normal SRv6 mode, or run it with an ether type. It's 100% optional.
Eric?
Eric Klein, sorry, I was bouncing around some other sessions. But I'll just say, as a six-man AD, I would invite everybody to read the six-man SIDS draft that Suresh has, where we also request a dedicated prefix for SRv6 that may be used to help things, that may be used in conjunction with this, or perhaps some other way. But please, if that's of interest, I invite you to review that document.
Thanks, Eric. And I'll just point out that I have spoken to Suresh as well. And from my perspective, and I can't speak for Suresh, I view this as complementary to that draft. It is not in any way in conflict.
Oh yeah, there's no conflict. Yeah, they can be used together in theory. Yeah, thank you.
Yeah.
Thanks. So we have a couple of minutes. I had closed the queue, but I guess this is good discussion. So Darren?
Yep, Darren Dukes. So you described the match that we defined in RFC 8754 as a LPM match. I just want a clarification on that. That's for the LPM you're talking about is for the single prefix from which we are allocating SRv6 SIDS, which is, I believe, in fact, just a prefix match. Is that correct?
It's a prefix, yes. And the prefix is matched by at least a longest prefix match in LPM. Yes, 100%.
Okay, I mean, it depends how it's implemented. Yeah, okay. So it's a prefix match in the TCAM, which turns into a single TCAM entry.
That depends on the hardware. I have seen hardware where when you implement per port ACLs, or per VLAN ACLs for that matter, you end up using more TCAM entries.
So if you have 1,000 ACLs and 1,000 different ACLs, then yes, you end up with more TCAM entries.
Yeah, you start hitting a problem. And there is hardware out there, because if you implement 4,000 VLANs, 4,000 ACLs, you're going to eat a couple of thousand TCAM entries. There is hardware out there like that.
Right. And okay, so a clarifying question on that then is, presumably if I have 4,000 ACLs deployed now, I've got some amount of scale on my TCAM. I probably have a pretty decent sized TCAM. Is that
No,
valid
because
or
you're
invalid?
assuming that those ACLs are actually in use. And for many operators, they aren't. That
So
just
they're-
doesn't happen. They are running
Sorry,
without the ACLs.
Okay, then I'll ask you to clarify that. How are we using 1,000 ACLs if we're not using 1,000 ACLs?
What I'm saying is, if I have to go and put this filter on 1,000 ports, I will be using 1,000 ACLs. And
unless
I've
you
done
just
this
use
in
one
a
ACL.
lab. If you apply that on a per port ACL command on certain routers that say, take this ACL and make it per port, because I may want to put something else on a filter on that port. So it becomes per port. Right there, that causes expansion on certain hardware.
Okay, so yeah, okay, so there are certain ways that you can deploy ACLs that are not scalable. Thank you.
Okay, thanks. Tom?
Hi there. I'm Tom Hill, BT. I'm also a co-author on this draft, just for everyone's information. I think it's important to remember that when we're talking about SRv6 and IPv6, that they really have not ever been the same thing. And it is important that we distinguish between the job of IPv6 and the job of SRv6. Okay? Yeah. The second thing that I have to really point out here is that it concerns me deeply that in a situation where I'm running an SRv6 signal transport network and I have a customer who is also receiving IPv6 transit from me, if they enable SRv6, how do I filter their packets? How do I filter? If they make a mistake and they start sending me SRv6 packets, how do I filter this? I mean, I don't even think it's possible for me to ACL them off, because they could just be using their RIPE or ARIN allocated IPv6 addresses as SIDS without an SRH, leak it into my network. How do I filter that? I don't think that's possible.
If you find the answer, let me know.
I think it's an ether type.
Okay. I would like to close the topic in the next minute or two. So, Tony.
Sure, Tony P. Jr. for last observation. So we resisted partitioning the IPv6 address space for many, many years for a good reason. Nothing prevents the next great technology group, another V6 block. We have 1 million of those things deployed. The moment you change the semantic of a V6 prefix, all these devices become non-compliant, right? Everything that is out there in the field will start basically forward this magic SRv6 prefix as V6, right? And unless you install this filter block, the devices will pass everything through. The default behavior on this prefix will not be dropped. If you go to ether type, the default behavior on an unknown ether type is dropped pretty much on every chip, every device, everything out there.
Thanks. Lorenzo.
Very brief comment. I mean, if you SRv6 is from a protocol perspective is IPv6, right? When you add a new ether type, you basically are forking it. So what could happen is that the new protocol is effectively independent, and now we can sort of ask ourselves, well, but like, what if we change this bit in the header? Or, oh, let's have a separate extension header registry for the new ether type. Or so essentially you're forking the protocol. I have no opinion. I don't know SRv6 very well, but this is what you're doing if you add a new ether type. And, you know, that's something that we should consider, presumably that you should consider carefully.
Yeah, just one comment on that, Lorenzo. I would argue that SRv6 is not IPv6, and it's a debatable point. From my perspective, SRv6 and IPv6 simply are not the same thing. I would also argue that, yes, we could argue that we are potentially forking the protocol, and I was well aware of that when I brought this draft to the inter-area working group, because if I take it to Spring is defined as saying that they cannot work on a new data plane. 6man works on the IPv6 data plane, and if I add an ether type, I fully acknowledge that this is not necessarily considered IPv6 anymore, though I would still argue that SRv6 isn't either. But yeah, as a last thought, we'd like to see more discussion on this. We'd also like to see adoption so that this draft is developed inside the working group. If people don't feel that this is appropriate for inter-area working group and would like me to take it somewhere else, we'd like to know where. And yeah, thanks very much for the lively discussion.
Thanks. So next in line is Sri.
Thank you. So this is a new proposal. This was posted to 6man. I'm bringing it here to INTAREA to get some feedback. It's mainly for discussion. Next slide. The context here is about emergency calling or Wi-Fi systems. So the question is, in many environments, a device will not be able to obtain its location. Let's say it's some indoor environments, there's no GPS signal. The device cannot know its location. Now, if it needs to make an emergency call, how can it provide the location information to the emergency systems? So that's the context of the discussion. That's the context of the problem. Next slide, please. So if you look at RFC 4676, there's a DHCP options where an endpoint can obtain the location information from the network. It defines 3 different variants. One is about network providing the client's location. Another is about it's a network's location. It's a point of attachment. And the third is a node closest to the endpoint. So it defines different semantics. So that's 4676. An end station using DHCP will be able to obtain this information. Other variant is RFC 6225. It's about geospatial coordinates. The endpoint can again, using DHCP, will be able to obtain the geospatial coordinates. Now, the similar semantics are missing in IPv6 in ND. If I'm obtaining, let's say, a DNS configuration or RFC 6106, I want to be able to obtain, and let's say I'm obtaining other parameters, let's say through PVD options or other things. Now, how can the endpoint obtain the location information from the network? So that's so the gap. The proposal is about, like, can we extend IPv6 ND to define new options? So there are three ways. I think there are different approaches to get there. Next slide, please. So one is define a new PVD option, essentially along what we did with 6106, right? One is for civic, another is for geospatial. But I think now again, as in DHCP, we can define similar variants, because in many indoor Wi-Fi environments with indoor localization, the network, like an access point, knows the precise location of the endpoint. So if you can provide that to the endpoint in the SIP signaling, it can be used, let's say, in the SIP P&E header, P-ANI, access network identifier header, it can include the information. So there is value in the call signaling. It will be of immense use, I think. So one approach is to, straight away define a new ND option for the same, replicate the same semantics as literally what is in the DHCP, the DHCP and the corresponding DHCP options, which pretty much use the same semantics and define a new ND option. That's one thing. Second approach, next slide, please, is Ulatron proposed a new draft on universal RA. Its purpose is to use the RMS as opaque carriers for configuration. But the draft, the working group did not like that. It didn't go anywhere. But now the question is, should we bring that back? And third option is, next slide, please. There is the PVD support now that it's the ability for the network to provide option, to deliver configuration options to the endpoint as PVD container is one thing, right? Now the question is also, like, is location a PVD, specific to a domain, or is it a global? I think that's, but at least semantically, we should be able to deliver location as a PVD option, right? Or define some JSON elements, allow the endpoint to use the URI to query the URI to get the location information. So different ways to get there. Now, last slide, please. Next slide. So now I think I got some feedback in 6-man. I think generally, I think there was one discussion on if it's a network location, there's no problem. If it's a client-specific location, DHCP is the right way because there's a client-specific identifier. But the counter argument is, when you do unicast, you have the same semantics. We do that unicast extensively for various use cases. So different ways to get there. If there's agreement on, if you see value, at least there's a use case. The emergency calling is a real use case. We want to be able to support that. So any feedback is appreciated.
Ben?
Hi, Ben Schwartz, Meta. So I went and glanced at the RFC, and this option is defined for DHCP v4 and DHCP v6. So I'm a little confused about why you think it's why that's not sufficient.
I think with the DNS, we have defined, if you look at 6106, right, we have defined the DNS configuration options. Using the RA, I'm able to deliver, the network can deliver the configuration. Along with that, if we can deliver additional parameters, this is the location you're in. The endpoint has all the configuration.
I would roughly describe the goal of this part of IPv6 architecture as making it possible to run an endpoint without DHCP. And it is possible, and it's certainly very possible to run an IPv6 endpoint without any use of DHCP. But that doesn't mean that everything that can be done using DHCP must also be able to be done without DHCP. And this seems like you've actually mentioned some pretty good arguments for why DHCP is an especially good fit for this metadata, because neighbor discovery is really about learning properties of my neighbors, and RA is learning about properties of the router, and provisioning domains are learning about properties of the domain, and that's none of those are exactly what you want. What you want is properties of this particular host, this endpoint, and that's the dynamic host configuration protocol.
I think that's a good comment, but I think we have already standardized, 66, the 6106, we already standardized 8801. We are already on that path. We are delivering configuration options to the endpoint. So I'm not taking, entering into the debate of whether DHCP is good or not, but if I'm able to operate a network with IPv6 only without using DHCP, I should be able to use the same for this as well. So, yes.
Lorenzo?
So a few points. First of all, I think the thing that you need to think of before you do any of this is what is your update strategy? Because different configuration mechanisms, different update strategies. DHCP's update strategy is you can't ever update anything. RAs are push-based using multicast, and those updates apply to everyone on the network, and so on and so forth. That is something you need to decide before you do anything. And location is obviously a thing that's not per client. It's actually per client per point in time. So that's one thing to consider. The other thing is please, and we will hit you over the head in 6 months if you try to do this. Please don't do anything that requires unicast arrays. RA is a push-based configuration mechanism. It's basically everything in the RA has lifetimes. It is fundamentally sort of push config. So don't do anything that requires unicast RS. A bunch of platforms won't do it. You won't have any update strategy. It won't end well. The other thing I would say is for RA versus PVD, generally speaking, I think when we were working on the PVD stuff, sort of the design team and the folks that were involved in that discussion were usually thinking along the lines of the RA is for bootstrapping information, stuff that you need to connect to the network, and stuff that ideally needs to come in one packet. And so there's a lot of things where the RA just fate shares everything because the single packet has the DNS configuration, the pref64, the PIO, the RIO, the RA lifetime, everything in one packet. This is probably not something that needs to be there. So generally speaking, I think the PVD is actually the best option here. And there is an update strategy for PVDs because I can't remember what it is, but there is a way to update it. Huh? Yeah, there's an expiry time, but there's also a refresh mechanism, I think, because we did that at the time. Well, no, I wasn't among the authors, but that it does have an update strategy. So,
okay, thank you, Lorenzo. Eric?
So, Eric Vink, again, the RFC 8801 co-author with Tommy. Those PVDs, right, can be generated dynamically, so it can be per host, like any web page, basically.
Yeah, Jelinkova, I actually wanted mostly to second what Lorenzo said, right? Also, I'm actually curious, just because your draft, I think it's very early stage, very short. What happens if you get in different array? We cover like multi-homing stuff.
Yeah, I think that's a good question. I think even to Lorenzo's point, right? I think we need to characterize the environment, right? If I'm operating this in a Wi-Fi environment, right? In Wi-Fi, we don't do broadcast RS and wake up every client for everything, right? I think that's one thing. And also, if you want to deliver a client-specific prefix, we do unicast RS. Unicast RA is not like some bad thing. We are doing it in wireless. It's in life, right? I think, yeah. So, but I understand. I agree what you're saying. But yeah, go ahead. Sorry. Yeah.
Q Meisel, some of what I've said has already been said by others, but I'd just like to say I might have some more to add. So I don't think this necessarily belongs in RAs. RAs are for, I've just connected to this network. How the hell do I route packets on it? This isn't a how the hell do I route packets. This is, it's important information, but it's something else. RAs are also multicast, so you give the same answer to everyone. You might want to say someone on this Wi-Fi access point get a different answer to someone on that Wi-Fi access point. You can't. You could kind of do that with RAs, but it would be messy. Let's not do that. And also, this is just adding more and more information into RAs, something which is constantly shouted out over the network. And we don't want to be making these massive packets which we're shouting out to everyone. This probably, DHCP-v6 might be an option. PVD seems like a more sensible option here. But, do one of those, don't do RAs.
Thanks. Thanks for the feedback. Yeah.
It's really just some quick suggestion. Because in the first slide, they show there are a picture about the 5G here. And then actually the 5G has already defined some very good technology for the positioning part. It's very accurate. So if you put there and then you try to do something overlay and have the IP to do the positioning part, actually it's way worse than what 5G the radio can do for you.
Yeah, I think I did qualify that this for Wi-Fi calling, so that we're not assuming there's 5G there. Yeah.
Hi, Ben Schwartz, Meta.
Ben Schwartz.
So first of all, on DHCP's update mechanism to Lorenzo, my understanding is that if the client really wants fresh DHCP metadata, it can rerun the DHCP Discover broadcast and get fresh metadata back. And so I think that if you're in this situation, I can imagine you make an emergency call, the phone doesn't have good geolocation, it emits that DHCP Discover like right now and gets an absolutely fresh estimate. So I think DHCP does actually suffice for that. If you do want to do this using provisioning domains, I would strongly encourage you to make the content of the provisioning domain JSON document itself static and move this location question into a separate service, because I don't want the provisioning domain to have to be dynamically generated. Ideally, I'd like to be able to, like, by hand in an editor, write out my provisioning domain JSON document and drop it on the file system. This is this dynamic thing is separate.
Got it. Thanks. Okay. Thanks for the feedback. Yeah.
All right.
Thank you.
So thank you very much. We went 1 minute about, but thanks everyone for attending INTAREA, and see you next time. You were not logged into the chat, right? People were asking questions there. I think next time it will be useful if you follow the discussion, because after you present it, then you can follow up and answer more questions.
If I log in now, should I be able to see that?
No, maybe in the minutes you will see it, and then you can reply on the next. Because there were a few people that didn't stand up to the mic, but still they were asking questions and making comments. It's usually good to keep an eye.
Okay. I had a question or comment on the statement of order. Isn't a very